Good morning, scholars. So today, or slash yesterday, we had this warm-up in preparation for the quiz on Friday that forced us to remember some things from very long ago. So some people asked, and today you have a video on how to do all of these things. So the first is target A is on rational exponents. So how do you transform these square roots into exponents, and then how do you deal with them to solve problems like solving equations? So the first thing is that the exponent, or the rational exponents, are equal to roots. So the denominator tells you the index of the root that you're taking, and the numerator tells you the power. So what that means for our right-hand side of our equation is that we can change that into a rational, i.e. fraction exponent. And the way you do that is you just take the index of the radical. It's invisible. In this case, it's 2 because it's a square root. Any other number, and there would actually be a number there to see. And so you just put the happy little 9 over the happy little 2, and that's it. So that has to be equal to the right-hand side. And then the big thing that you have to remember with your powers of exponents is that they add on the left. So that's 3 to the x over 6 plus 5 over 4 equals 3 to the 9 over 2. And then because of the properties of exponential functions, that means the exponents actually have to be equal. So you get x over 6 plus 5 over 4 is equal to 9 over 2. And you have to solve that. Now that's kind of annoying because there's a bunch of fractions. The easiest way to deal with it is just to multiply by the least common multiple of the denominators and get rid of all the fractions. So if I multiply both sides by 6, then the 6 and the 2 will go away, but there will be a 2 left in the 4. So I actually probably have to multiply it by 12. So now if I multiply the whole equation by 12, 12 divided by 6 is 2, so I'm just going to get 2x. Oh, little mistake there. Don't know how to fix it. We'll just leave it. It's fine. 12 divided by 4 is 3. 3 times 5 is 15. And then you have 12 divided by 2 is 6. 6 times 9 is 54. Now that looks like an equation that we can solve, so we subtract 15. You get 2x is equal to, looks like a 9 on the end there. And then, is it 39? Yep, seems so. Divide both sides by 2 and you get the answer. So, not so great. Might have made a mistake, but that's a right process. If I find the mistake, let me know in the comments. Second problem. We need to write the following in vertex form. A times x minus h squared plus k equals something. So this target E is all about equivalent forms of expressions. So it's usually you've got some expression, you need to change it into something else. Could be an exponential, like in level 1, could be a quadratic, like here. More than likely it's going to be a quadratic because we're studying quadratics at the moment. So this one's going to be, one way to find the vertex is h is negative b over 2a. That was in our foldable. So if we write down what a, b, and c are, so a is the coefficient in front of the x squared, which is 6, b is going to be 11, c is going to be minus 10. So just going to write that down. A equals 6, b equals 11, c equals minus 10. All right, so this negative b over 2a thing, well, that's equal to negative 11 divided by 2 times a, which is 6. So that's negative 11 over 12. Well, that's gross. All right, so then you need to plug that in to find k. So that means k is going to be 6 times this negative 11 over 12 squared plus 11 times negative 11 over 12 minus 10. Whatever that number is. If we want to figure it out, I mean, I guess we can, but it's going to be messy. So we'll leave that as a dot, dot, dot for your calculator, and then you would just write it as a, which is 6, times x minus negative 11 over 12 squared plus whatever that k thing was. Hopefully the problem on the test will be a lot simpler. It will be. It'll come out even. It won't come out all disgusting and gross with fractions, because that's not what we're testing you on. All right, next one down. Solve the following equation for k. So, got a couple of different ways that we can do this. We could factor it, or we could graph it. Don't know any other ways at the moment. We can try factoring, see what we get. So in order to do that, we need to get everything to one side. So you subtract 22 from both sides. You get 3k squared minus 15k minus 22 equals 0. Check the no greatest common divisor. That doesn't work. All right, so go to our cross. You have 3 times 22 in the top and minus 15 in the bottom. So that gives us 66. Factors of 66 that could possibly work. Well, you could have 1 and 66, both negative, or one of them's negative. Negative 66 has to be negative. Doesn't look like that works. Gives you negative 65 when you add. All right, next number up from 1 is 2. So that would be 2 and negative 33. That doesn't work. Add together to give you minus 31. 3 goes into 66, gives you minus 22. 3 plus negative 22 is negative 19, getting closer. 4 does not divide into 66. 5 doesn't divide into 66. 6 is the next answer. Goes in 11 times. And now we're going to be too small. So it does not look like it factors. Well, that's gross. So the only thing that we can do is bust out Desmos. So get our handy dandy graphing calculator and then type in our equation. All right, so it's 3x squared minus 15x minus 22 equals 0. All right, so there are two solutions. So x is equal to negative 1.186, or x is equal to 6.186, apparently. We'll see later on how to get those algebraically, but for now, have to use a Desmos calculator. Don't have another way to do it. All right, moving right along, we have, thank you, Desmos calculator. Goodbye, Desmos calculator. We have target M, which is about comparing and contrasting different forms of equations and looking at features. So we've got parabolas. So one of the features we know about is a max or a min, and we've got two different forms. So it could give you a graph. I chose to give you a table and an equation on this problem. So it's looking for the largest maximum. Well, the largest number for the maximum always goes with the y value. So we're going to look down in our table here and see that the maximum value of g looks like the 0 thing because you're subtracting 3 on both sides of it. Means that's probably the vertex. So in our f equation, if we had the equation in vertex form, we'd be done. It's not, which is annoying. So try to use that negative b over 2a thing. So our a is minus 2, b is 8, c is negative 7. So negative b over 2a is equal to negative 8 over 2 times negative 2. All of this simplifies to positive 2. And now to find the maximum value, you have to plug 2 back in to the equation. So f of 2 gives you minus 2 squared plus 8 times 2 minus 7. So that is minus 2 times 4 plus 16 minus 7, which is 1. So 1 is bigger than 0, so f actually has the largest maximum. All right, so then moving right along, target N is mainly dealing with different forms of function notations or different forms that functions can be written in. So you've got the explicit formula where you can just plug in and you get out the value. So either a linear or an exponential. And then you've got the recursive formula, which gives you the first term, and then it tells you how to get the next term. So this is, the first term is 10, and then you multiply by 3 to get the next one. This first term is 3, multiply by 10 to get the next one. First term is 10, add 3 to get the last one. So looking at these recursive formulas, so I said the bottom one here, first term is 10, that sounds a lot like it's not quite the y-intercept, although it sounds like it. So first term is 10, but you're adding 3 each time. Well, that's a constant rate of change, so that should be a linear function since there's only one linear. Seems like the middle down here is a good choice. And you should be able to go through that thought process and explain it on your paper just like I did. So maybe, actually, if we wanted to erase that, maybe what we'd say is something like m is equal to 3, which is why we're choosing this particular equation. All right, so then we've got 2 recursive functions. This one is multiplying by 3, and this one is multiplying by 10. That usually matches up with the base of the exponent. So here you're multiplying by 10, and here you're multiplying by 3. So that means that our graph should be shaded like this. And then we should just give some sort of reason. So, you know, you can just say exponent equals 10 or the base equals 10. Not looking for anything complicated, but I do need to be able to see your thinking. And that's it. Have a great day.